Hello everybody, my name is Sam and welcome to the third episode of Rust Fasttrack. In today's episode we're going to talk about mutability, but first I want to make a correction. In the last episode I referred to slices as an anonymous data type. This is a complete lie and I have no idea why I said that. Let me explain real quick. An anonymous data type is something that the compiler generates as a sort of auto-generated type which it uses for referencing, and you can't directly reference as types. You have to implement you have to use a generic on traits that type is made to implement by the compiler. We'll get more onto that when we talk about traits and generics and all of that magic. Just know that I was talking some bollocks there. I need to not do these at 10 o'clock at night, and so instead do them at 11 o'clock in the morning. Anyway, so today we're going to talk about mutability. Oh yeah, I also added in U8 because I missed it last time somehow. So yeah, mutability. So what is mutability? Well, mutability is the idea that something can either be mutable and can be changed, or immutable and can't be changed. Now, a lot of programming languages would be completely fine with you saying, like, let v equals 8 and then redefining v as 4. So then they would be completely fine with you doing something like this, but let's actually see what happens if we try and compile this. Again, this is compiling, not running. So just on the compilation step, what? Oh, syntax error. Where? Oh, here. Okay, I've just fixed that behind the scenes, don't worry. It's just in where I added the U8. There we go. Reassignment of immutable variable v. So v was assigned here with let v equals 8, and then we tried to change it to 4. So you can't do that in Rust. If you want to ever change something, then you have to mark it as mutable. And this is something I really like, because the majority of the time you'd be surprised your variables don't actually need to be mutable. And so making immutable the default and making mutability explicit, I really like as a feature. A lot of languages have const that you use for constant values and immutable values. In Rust, consts exist, but I believe they're essentially just static immutables. I'd have to look more into the actual back-end implementation of them to be able to tell you exactly what they are, but I believe they're just static immutables. That's immutables with a static lifetime. Again, we'll talk more about that in the lifetimes episode, which will be the next one. So, we've looked at this. Let's look at something else quickly. Yeah, so let's say we have an array. Man, I'm running out of letters. So we're going to let mutable w of an array of 3 i32s. We're going to let it be 1, 2, 3. So this is mutable, so we can then say w dot 2 equals... can you use dot syntax with these? I'm not actually sure. Let's find out. Let's try and run this. So we've made it mutable, and yeah, it doesn't like the dot syntax. So dot syntax only works with tuples, not with arrays. So you have to do a more classic array indexing format here. Okay. And it built. And you can see v is 8, v is 4, w is that, w is that. So you can see that the mutability is applying to everything inside here as well. So basically, it's just, I'm trying to show off sort of how mutability works. So you're probably thinking, okay, so if I ever want to change something, I've got to mark it as mutable. Well, what if... No, let's just leave it at that. So if you want to have a variable that changes itself, you've got to mark it as mutable. Okay, so a variable cannot change its value if it is not mutable. What you can do is shadow it. So I'm going to write some completely valid code here. change this to x. Okay. Okay. So you will see here this is not mutable. We said let x equal 8 and then let x equal 3. Now this is a thing called shadowing in Rust, and this is where you actually overwrite a name. So we've said let x equal 8, and then down here we're just redefining x to be 3. And this is a way where we can actually get around this need for marking stuff as mutable. However, I would advise against this. There are times when shadowing is absolutely the correct thing to do, especially when you have scopes, because if we nest this inside a scope, then, and I'll talk about this more in lifetimes, when this value of x gets consumed, this one just becomes available again, and so the shadowing kind of like unwraps itself. I didn't mean to do that. I meant to do that. But if we run this, you'll see that does exactly what we expect. And so you also have this idea of shadowing, where you can essentially alias and overwrite something. And what I'm going to do, I'm actually going to... This is technically more talking about lifetimes than anything else, but let's just really quickly demonstrate by doing this. Okay, and so now we should get 838, and we do, we get 838. And so here what we've done is we've said, we're just going to shadow x, we're going to overwrite this x just within this lifetime, and then this value of x gets consumed at the end of this scope, and we're back to being able to use our old value. And so I'm just going to rename this like mutability and shadowing. I think it's called shadowing. I'm going to double check that. I'm pretty sure that doing that is called shadowing. That's what I've heard it called in the past. And in the Rustby example, it is called scope and shadowing, so yes. Okay, the other thing you'll know is here I've just made an empty scope. This is very much something that's going to be touched on in the Lifetimes episode, and not so much this one. So this has been a really short one on mutability, and next up we're going to talk about lifetimes, and that's going to get a bit more complicated, because I'm going to have to talk to you about traits, I'm going to have to talk to you about these scopes, I'm going to have to talk about all sorts. So yeah, let's go do that now.